Here on this tab, there are two main unit system, US and SI. All the other countries here, we use SI. This is, we are going to develop this to shows us the language. For example, when you click this, then you have different languages there, but basically they are still SI unit.
This is a test file, and the required capacity is 278 kbs. So here, band 3, required capacity is 139 tons, which is 278 kbs. Minimum tip is very deep, so we need to get to that minimum tip though. Minimum tip is minus 36. So that's why we still need to have to keep driving to meet the minimum tip. The reference elevation is 9 point something. So let me see. Let me ask Louis to. So this is a stress. Stress, compression stress is okay. Tensile stress is the black one, is very low. Stress for each blow. Compression stress is still about 70% of allowable. Capacity is way off the way higher than needed, but we need to drive past minimum tip and 10 feet of bearing per FDOT specification. Why 10 feet? I come back later. Not 2 feet. For production pile is 2 feet, but for test pile, this is a test pile. It's a little bit confusing in this aspect, but I'll explain later. So let me ask Louis to increase fuel setting. Please. Okay, so so the total blows is here. Total blows 290 something blows now. This is the blow per foot. The previous foot is 37 blows per foot. This is the current foot, which is from 30 to 31 foot mark. So from 30 to 31 foot mark is counting. Okay, so Louis said that it's just increased fuel setting to 3. Fuel setting to 3, okay. And we still on 30. What? Okay, yes. 30 foot mark here. I think that's what he meant, 30 foot mark. Foot mark 30 feet. Okay, so he's just increased the foot mark, and that we have 54 blows per that foot. Between 30 and 31 foot, we have 54 blows. Capacity reduced a little bit now because the soil is softer. So when let's view this. So accelerometers are perfect. Velocity is integrations of accelerometers, and the record is perfect. The two accelerations, velocity record almost the same, so it's perfect. There's some gap here, which indicate a little bit of bending forces. On side number 1, it's a little bit higher force than on side number 2, which is okay. We don't need to do anything. When there is a status up here, we'll see later on, it shows up that it will say bending 3 point something, for example. Then we may need to be, it just show up, and it disappear. So just one blows, it says bending something, but still it's not that critical yet. So the record so far is perfect. Okay, let's go back to the plan. So on the plan, this is band 3. We tested band 4 last week. We still haven't finished pi 654. They are doing pi number 7 right now. Whatever is the black, that is in the designated test pi. So we are on pi number 7, which is the designated test pi. So in Florida, it's a little bit funny that all the pi are being tested, but there are some pi that are designated test pi, where the other pi are designated as instrumented production pi. So Basti is picking up more now. Let's look at the stresses. So earlier, when we increase the fuel setting to fuel setting number 3, then top compression stress increased. The toe compression stress also increased slightly because there's a little bit more force transfer to the toe of the pi, and it will be reflected in the energy and stroke height as well. So this is the hammer stroke height. When you increase the fuel settings, then the stroke height increase from about 7 point, here is about 7.7 foot to around 8 point something. So each blow, it has the diesel hammer, each blow has its own stroke height, and it's displayed here. So right now the stroke height is about almost 9 feet. 9 feet stroke height, which is pretty high for fuel setting 3. So we keep that. So we don't need to go to 4 right for now. Pretty high stroke height. Back to test designated test pi and production pi. So test pi in Florida need to have a minimum of 10 feet in bearing zone, which means it need to have a minimum of 10 feet exceeding capacity, exceeding the required capacity, and in general, increasing trend. So we do have it now. We do have it now is about foot mark 35, and earlier when we start to have, let me see. So you can click on this button. It's during this button during the drive. The last foot, which is right now, the last foot there is not updating until Louis hit this button. So when the foot mark toe stress is high, all right? Toe stress is high. So let's see, it's yellow, so toe stress is high, but we increase this up. So what I did there on the other screen, I increased the. I don't want to go to that screen for too long because because Louis need to hit this button, which he just did. Okay, so here, I just increase this threshold, trigger level. The reason is there's one or two blows there where it trigger where the not a real blow, but it trigger the blow. So I increase the threshold so that only a good blow will be received instead of the noise blow. So we are driving into pretty hard limestone now. We have 105 blows per previous foot. That means it's pretty hard soil. Again, this is not updating until he hit the next foot mark. But what I'm trying to say is we start to have resistance around foot mark 25. Okay, so 278 K is the required resistance. So we have a resistance around foot mark 25. And right now we have foot mark 35. So we already have more than 10 feet of resistance, but we need to meet minimum tip. So that's why we still keep driving. Minimum tip minus 36. Reference is 9. So that means we need to drive to foot mark of 30, 45.2, 9.2 plus 36, so 45.2. We need to drive to a minimum foot mark of 45.2 according to FDOT specification. And according to this design plan. So now I can increase the scale here temporarily, but it will fall back right back to the default because the required capacity is only this. So that's why it doesn't display much higher. I can temporarily click on this and change this scale. Oh, it's changed right back. I have to pause I have to pause the drive in order to change the scale. But anyway, we don't need to see high capacity anyway. It's really high here. The capacity is here. Case method is more than 1,000 kips. Signal matching is more than 1,000 kips here. Toe stress is high. Toe stress is really high now. Toe stress is high, and at some point, it's pretty high now. At some point, I need to, if it stay red for a couple of blows, red means danger. Yellows here means warning. So red, yeah, that's danger. So if it stays red for a couple of blows, then I would tell Louis, oh, that's pretty high. To go down on fuel setting 2. Let's see if stay red for, oh, that's pretty high. Going down to fuel setting 2. That's pretty high. Always. Okay, he's reduced fuel setting 2 now. So he just reduces to fuel setting 2, I think. Yep, he did. So, stress is still pretty high. Wow. Even the fuel setting 2 is still pretty high. And when we reduce the fuel setting low, but still high. when we reduce a few settings, we see if the soil is still, let's see, the stroke height drop on fusing 2 there. Okay, now it's fusing 1, I think. Now it's fusing 1, and so stress reduced now. But the thing is, when you reduce the fuel settings, and if the soil is still way too good, then this future number, we see it like this number may be a lot. Oh, stress climbing back high, even on fuel setting 1. Even on fuel setting 1 is high. The limit that we set is 3.5. So we set the limit 3.5 on the first screen. Let me go real quick there. So 3.5 we set in the beginning, 3.5 for compressive stress, and whenever it exceeds 3.5, it show red, pretty high. High again, which generally we don't want to exceed for too long. The real limit, though, is about 3.8, the real stress limit, because in Florida, there's an equation to calculate it based on the concrete strength and based on the pre-tension stress. And if you use the formula to calculate, it's the allowable compression stress is going to be around 3.8, but we put in 3.5 on the. We need to stop here. It took some pictures. This change cushion from XY. Yeah. Yeah, that's obvious because of the stress here, but we have difficulties getting to minimum tip now. That's the challenge here. Stress is high. Stop at 38. So see the blow count. Blow count is increasing. And if, let's see what's going on with the blow counts. If the blow count is 240 per foot, or more than 240 per foot, according to FDOT specifications, then, well, this is high. Then we are not allowed to drive. Furthermore, we have to stop. Oh, stress way high, even if you're sitting 1. Check. Yeah, this is a fuel setting 1 stroke height. So on diesel hammer, it even exceed a few blows, even exceed 3.8. Now there's no damage. There's no toe damage. As you can see, toe reflection is right at the right point. So no damage on this part. Even though the stress is really high, but no pie damage. The deflection, the reflection is at the right point. The blow count. Yeah, we'll stop. Okay. Wow. It's just coincidence that it's 240. So it's 240 240 blows for that foot, which is practically refusal. We still 7 foot above minimum tip. We already have 240 blows per foot on field setting 1. So if we have a brand new cushion, the brand new cushion will soften the blow more, will transfer less energy, and because of that, we will have even more than 240 blows per foot. And according to FDOT specs, we cannot drive more than 240 blows per foot. We already at that threshold. So with a new cushion, most likely we'll have like 300 blows or 400 blows per foot. We can try. We can try, and if we get lucky, we can go to the softer soils. Then all's good. The soil below this, yeah, the soil below this may be softer. Who knows? But we can try. We can try. This looks good. 3 point something there. Increase now. So what you do is you click on this button here to readjust the scale. Just keep driving, see what's going on. It's very high stresses. I'm going to stop. Stop because it's still very high stresses. Even obviously with the new cushion, it would not help on the toe. Energy is still transferred a lot, so 53 to 54, 53 blows. The new cushion, the stress at the top of the pile would help the stress at the top of the pile, but other than that, the stress at the toe is still pretty high. 3.6, 3.6 here. Sometimes there's one blow 3.7. Yeah, 3.8. Yeah, so still pretty high.
In the live presentations, there was a question in the chat room that I didn't see until the end of the presentations, is why DFN is 0 for a lot of blows. That is because the accelerations always has some minor, extremely minor error. So this is a perfect record, and despite that, it still has some extremely minor error, which I already presented in numerous presentations in PowerPoint and videos. And because of that, the DFN is not as accurate as the MX. So when you have a good high driving records, the LP record, okay, so this is a Pi Inspector record here, then when you have that, you switch the blow count match level to any level higher than 0. Okay, so I switch to any level higher than 0, then there will be the record will be adjusted according to this LP table, to the pi driving record. So you see here now DFN is not 0 anymore, it's 0.1 because it's adjusted according to the LP table. So this is exactly the same as what PDI does in their program. So that is the normal practice. So now you can see, let me go from below 0 all the way down, below 1. So I'm going down or to various blows, and the DFN there is just the inverse of the recorded blow count. So if I have the match level anything other than 0, this record will be adjusted. The accelerometer has a minor adjustment. So here, toward the end here, is almost 0 as well, because the blow count is very high. The blow count is 241 per foot. Of the last 2 inches is 51 blow for only 2 inches. So inverse of that, inverse of these two numbers is approximately 0 as well. So that's the reason you have the DFN close to 0 here as well. Now, let me go back up when the record, go back up when the DFN is 0.1. So 0.1 is here, below 740. So that is, below 740 is somewhere here where the blow count is 95 per foot. So when the blow count is 95 per foot, inverse of this, you will have this DFN there. Now when I change this to match level 0, it back to the raw data. So the raw data, the DFN is 0. That's the raw recorded data. Now, when you switch to match level everything other than 0, now you have to run INGAPA first. I did that. I already rerun the INGAPA with this different match of level there. So that's it.
They move it to pi number 6. I'm not going to talk much about during this pi unless something comes up, because I'm going to multitasking. I'm going to work on different things when I'm monitoring as well. So because of that, I'm not going to talk much, and I'm going to work separately on my second screens on different stuff. Means the accelerometers on number 2. What I driving, and Louis. Louis is not on the drive mode yet. That's why this is still collecting data, though. It's still collecting data, but he's not still collecting data, but he's not on driving mode. So this filter point here is the filter point just for the vertical graph. The data currently has no filter. So filter point to the data is 0. On the vertical graph, you can do filter here. So because each blow has mobilized different resistance, so you can do the filters, make the presentation smoother. No, maybe just the way the hammer drives. Sometimes it's just the way the hammer drives. Sometimes it's too on one of the side is too off, and it causes that. Okay, they put one case upside down and one guy side up. So let's see. So V1 is upside down, V2 is right side up. So V2 is right side up. We need to change the replay factor as well. So replay factor of V2 will be negative. V2 will be negative. number 6. And let's see the elevations, the revised. We cut off which pi, we call him, of the neighboring pi, I guess. Let's see the pictures. Oh, this is easy. Just use ground. We call Louis. Hey, Louis, this is easy. This is easy. Just use ground. Just use ground as reference elevation. Yeah, just use ground and ask them to survey the ground elevation. Survey the ground elevation and give us back the survey ground elevation. Okay. All right. Yeah, bye-bye. So earlier it was 40, right now it looks like this is actually 40 and a half. When we stop it's 40 and a half. And right now it looks like it is 34, maybe 35. The way they mark it, so it's 35. 35. So it is 5.5 feet difference. So most likely 5.5 feet difference will be 8. 8. Want to update all LP for the new reference elevation? Yes. You update all the LP. Okay. And so the LP and the last LP now will be 35. Yeah, 35. So it will use reference elevations. Most likely it's about 8. Let's see if I'm correct on the reference elevation. It's about 8. So to resume the previous drive, just open existing file, append, and this is convenient because then that way, when we resume, we don't, because this is the same file, we want to keep the same wave speed as the original drive because it's the same file. So it's very convenient. You don't have to guess what is the wave speed. You already know the wave speed from the initial drive. That's one benefit. The second benefit is the LP will be continuous. And here, if you have different reference, you just update reference elevation. Because earlier it is 13.4 because it has a template. It has a still template, which is similar to this. So earlier it used a still template as a reference. Now they have to remove it in order to keep driving. And as they remove it, there's no original reference anymore. And we use new reference elevations. And as such, all the LP will be changed accordingly. So what's the reference elevation? About 8? Are they done putting on the sensors, or they're still working on the sensor?
Say that again, sorry?
Are they done putting on the sensor? Are they done attaching the sensor?
I don't. Rudolph is 5 feet. Oh,
Are they done putting on the sensor?
the center?
Are they done?
Yeah,
They're ready to drive, right?
yeah.
Okay. And do you have the ground elevation? No. Ground elevation, not template. Template is gone. Template is gone.
No, I don't have the ground elevation. They didn't know.
Okay, we can find out later on. They have a survey. They do have survey. We can find out later on. Okay.
Okay.
Go ahead, dry. Go ahead, dry.
Okay.
Oh,
Okay,
yeah,
okay.
bye-bye.